Hello, welcome to another class with Physics Anchor. Today we'll be solving more questions from JAMB past questions for the benefit of those students that will be writing JAMB. And today we have 3 questions on the board from the topic linear momentum in physics. So let's get started. In question number 1, we have a constant force of magnitude F acts on an object of mass 0.04 kilogram, initially at rest at a point O. If the speed of the object when it has moved 50 meters from O is 500 meters per second, what is the value of force? So in our culture, let's start listing out our parameters so that we can know the exact formula to apply to what they want us to find, which is the value of force. So we have mass, we are working with mass 0.04 kilogram. We know that what these had been at rest, okay? So let's just state it, whether we will need it or not. Let's state it, U equals 0 meter per second. If the speed of the object when it has moved, so the speed, which is V now, is 500 meter per second, and the distance S is actually what? 50 meter. So what they want us to calculate is the value of what? F. Same mass here and looking for force, which is what? F. We remember the formula F equals to what? MA. So this formula will be a very good one for us, but unfortunately we do not have acceleration in the parameters given. But by looking at, okay, VSU, okay, we can actually find our acceleration, okay. The formula combining A, V, U and what? S together is the formula V square equals to U square plus 2AS, okay. So we can use this to get our A and then we come and apply it to get our F. So we can say our V square, which is what? 500 square equals to 0 square our U plus 2 A that we are looking for and our S, which is what? 50. So that will give us 250,000. That's 250,000 equals 2 times 50 will give me 100A. So my A acceleration will be 250,000 over 100. Let this cancel this. So that will be acceleration equals to 2,500 meter per second squared. So this has given me my acceleration. So from that, now having my acceleration, I can calculate my F. F equals to MA. Our mass is in its SI unit, that's 0.04, times the acceleration that we already have now, which is, let me write that so that it will, F equals to 0.04 times 2,500. So that will give me 4 over 100 times 2,500. 0 cancel 0, 0, 0. So 0 here, 0 here, 0 here, 0 here. So the F I have will be 4 times 25, and that will be 100 what? Newton, because we are calculating force. So let's go and check our option. Not A, okay, that's B, 100 Newton. So our force is 100 Newton. I hope you understand that. So that's straightforward as that. So you just need your formula to get this done. Let's move to number 2. Question number 2. Okay. Question number 2. A force of 200 Newton acts between two objects at a certain distance apart. The value of the force when the distance is halved is dash. So in other words, so the distance is being reduced by half, okay. So now they want us to know the force, okay, the value of the force when the distance is halved. So let's first analyze this. We know that F is equals to MA, okay, because what we have here now, by analysis, let me list out what we have here. We are going to have something we call F1, okay. because now we are talking about two different values for what? Force. So when we have F1, that's F1 equals to 200 Newton, and we have what we call S1, okay? That's the distance 1, okay? They are now asking us that what? When that's the distance 2 now is equals to half of S1. That is when the distance is halved. When the distance is halved, meaning that what? It is what? Divided by 2. It is divided into 2 equal parts, okay? That will be the distance 2, okay? Which will be S2 now will be S1 over 2, or we can say that what? 0.5 S1, okay? Let me write it like this. That's half S1. That will be better. Half S1, and that will be 0.5 S1. That means that what? S2 is equals to 0.5 S1. Now, the only thing we have in this analysis is just force and distance. So it means that if we are to really get this right, we have to establish the formula connecting force and distance together. But we have fundamentally that what? Force equals to what? Mass times acceleration. So from here, we can say F equals to mass times velocity over time, which is our acceleration. Our acceleration is what? Change in velocity with time. So from this mv, we also know that, okay, our velocity, let's write it this way, that's mass times v times 1 over t. So this is what this one will become. That's mv times, so it will still be like what you're writing mv over t. So what is our v? V is velocity. So we can further split our velocity to distance over time, okay? Our velocity is displacement over time, or I'm just using distance over time this time around because I'm not paying attention to direction. So just the magnitude. So times 1 over t, then I can say F equals to ms, okay, over t square. So I can say mass times distance over t square. That is my force. So now let's use this relation now. For the F1, I'm going to be having something like this. F1 equals to, since the mass is constant, that will be S1. They did not give us any value for t. The time is still constant in this case. So they didn't give any reference to what? The time. The time is still what? Constant. So, and my F2 now, okay, which will be the force we are looking for now. That's when the distance between the what? The two, that's the distance between the two objects now, when it is what? Being halved. That will be F2 equals m, which is constant, now S2, okay, over t square. But in this case, instead of writing S2, I'm going to write the value of S2, which is what? 0.5 S1 over t square, and that will give me 0.5 ms1 over t square. So let's take the ratio of F2 over F1. If I take the ratio of F2 over F1, so I'm going to write the value of this, my F2. What's my F2? My F2 is 0.5, okay, you know, this is what I want to write, F2 over F1. So what's my F2? My F2 is 0.5 ms1 over t square. This line means divided by, what is my F1? Let's go back. What's my F1? My F1 is what? ms1 over t square. Okay, so that will give me F2 over F1, okay, equals 0.5 ms1 over t square times, okay, inverse of that, t square ms1. So we can cut now. M cancel M, S1 cancel S1, t square cancel t square. So what will remain is, okay, let me do something, okay, so that since we have solved number 1, let me give room for the solution. I don't want to just squeeze it in. I want you to see it clearly. Since I've actually solved number 1, I can clear that one. So that will mean F2 over F1 equals to, what I will have left here is 0.5 over 1. That's what remains. So let's cross multiply. F2 times 1 will be F2. F1 times 0.5, that will be F 0.5 F1. So in other words, F2 is equals to 0.5 times what? F1. When you go back to the question, you can see that the value of F1 has been given, which is 200 Newton, okay? So since my F1 is what? 200 Newton, I'll just put it 0.5 times 200 Newton, okay? That's what? 0.5 times 200. That will be half times what? 200, which is what? 100 Newton. Therefore, F2 is equals to what? 100 Newton. And that is the second force that they want you to find. That's the value of the force when the distance is what? Halved. So what it means that when the distance is halved, the force is also halved. When the distance is divided by 2, it's just like what? The force also, which is was initially 200, was also divided by 2. And then we have what? 100 Newton. So let's check the option. So A, 100 Newton. So we have our answer already. A is the what? Correct what? Option. Okay, this is how you go about question like this. You have to compare, okay, formula, and then you try as much as possible to cut out the what? The constant, so that you can have the clear ratio that you are looking for. All right, so let's move to question number 3. I hope you understand that. Please watch the video until you have a clear understanding of what we have just done. Number 3, an engine, okay, an engine of a car of power 80 kilowatts. I want to be writing that directly. Power is 80 kilowatts, okay, moves on a rough road with a velocity of 32, okay, velocity equals to 32 meters per second. The force required to bring it to rest is dash. They are asking us what? To calculate what? The force. So in this question, I can only see power, velocity, force. So in other words, we have to find a formula that will actually connect these together. All we know here is that our power is work done, okay, over time. Okay, work done over time. And we know that what? Work done is what? Force times what? Distance over time, which we can write as what? Force times distance over time. What is distance over time? Distance over time, or displacement over time, is what? Velocity. So that's F times what? Velocity. That means that what? P equals to what? FV. That is what? Power equals to product of force and velocity. So now we have established the formula. So we have power, we have velocity, we are looking for what? Force. I'll just say my force is equals to what? Power divided by what? Velocity. What's my power? My power is 80, okay, 1,000, because this is in kilowatts, okay? I cannot use it in kilowatts. I have to say power equals to 80 times 1,000 watts, okay? You convert that, that will be 80,000 watts, okay? It is the watts that is the SI unit of power. Meter per seconds is the SI unit of velocity, so we don't have to convert that, and that will be over 32. 16 year 2, 16 year 5. Yes, 16 year 5. Then I have 0, 0, 0, so that will be 5,000. Okay, so I have 2 year 1, 2 year 2, 5, 0, 0. Okay, so that means that what? The force is equals to 2,500, okay, Newton, and that will be, if I want to do that to the way they left the answer, when you look at it, they left the answer in standard form. I'll just do 1, 2, 3. That will be 2.5 times 10 raised to 3 Newton. Just count it backward. 1, 2, 3. So 2.5 times 10 raised to 3 Newton. So where is the answer? Where is the answer? That is C. 2.5 times 10 raised to 3 Newton. Okay. And this is the solution for the 3 questions we have under linear momentum as a topic in physics. So I hope you understand the little we have done in these past questions. Try to lay your hands on questions like this. And if you have any questions that bothers you, please put it in the comment section for me to actually do justice to, for everybody to learn. Share this video, Keep on studying, keep on learning. Subscribe if you have not done so. Hit the notification bell if you have not done so. Till next class that I will be coming your way with more questions from JAMB Past questions. I wish you all the very best in your examination. Bye for now.